Okay, and lastly, before I conclude the section, right, as I've said, I've done everything in the following way. We first learn it dealing with numbers only, and then we start incorporating variables. So exactly as we did LCM with numbers and variables, now when we have fractions that have variables in the denominator, it's going to be fairly straightforward, right? So it's like 1 over 2x squared plus 1 over 4y. Then how would we do this? Same steps, same idea. Everything's the same. Your step 1, because the denominators are not the same, it'll be 2x squared and 4y. And 2 will break down into 2, 4 will break down into 2 times 2. X squared breaks down into x times x, and y will just remain on its own. Okay, and then to get the LCM for the denominators, or the LCD, we take the shared and multiply it by the unshared. So this 2 and 2 will be shared, and then this 2, this x, and this y here will be unshared. And so therefore we have 2 times 2 times x times y. Right, so this all makes up your unshared, and this makes up your shared. And so therefore, if you have to multiply all of this, it'll be 2 times 2, which is 4, x squared y. What's your step 2? New denominator over the old denominator. So 4x squared is your new denominator. So for the fraction 2x squared, we'll have 4x squared y over 2x squared, which is equal to 2y. And for the fraction 1 over 4y, we have 4x squared y over 4y, which is equal to x squared. What do we do with these factors? We multiply them by the old fraction. So we multiply this fraction. So for the fraction 1 over 2x squared, we multiply by 2y over 2y. And for the fraction 1 over 4y, we multiply by x squared over x squared. Right, and now let's simplify. Very straightforward. So if we simplify, this will be 1 times 2y is what? 2y. And 2x squared times 2y is 4x squared y, plus 1 times x squared is x squared. 4y times x squared is 4x squared y. Now can you see that we have both the same denominators for both these fractions? So now I can simply add. So it'll be 2y plus x squared. And this is what we call unlike terms. So therefore we cannot add them. And therefore your denominators are the same. And that's how you simplify this question. Now, there's something after I discuss exponents, factorization, and algebraic expressions, there's another idea that I need to add here, because initially, when you have a number over a number, and you need to write this down, when you're dealing with an integer, so some number over some number, this is what we call a fraction. A fraction. When we have numbers in the numerator and numbers in the denominator. But when you start having variables and numbers, so numbers plus variables over numbers plus variables, right? In fact, we don't put the plus. Let's just say numbers and. Let's just say numbers and variables. Numbers and variables. Then what we have is what we call rational expressions. I can only talk about the section more in depth after we complete algebraic expressions, touch on some factorization and exponents. Then I can talk about this topic in depth. This is why I'm saying we are building a story, so you have to follow the ideas. If you miss out one video, there's something that you're going to miss a link. You're going to miss a chapter in the story, and you're not going to understand the story. But for now, I'm going to add this here. X cannot equal to 0, and y cannot equal to 0. We're one of the very few people that actually add this here. It's actually ignored in some of the papers, and it's incorrect, and I'll explain exactly why this idea is so important, why adding this, what we call restriction, is very important, because division by 0 is what we call undefined. Then it actually makes the entire question wrong if we do not add this. Right? And it's an idea that's only talked about in depth at university. So I'm actually bringing this to your attention at a very early stage. So as long as now you have the necessary information, but for now, like I said, just copy this as it is. By the end of term 1, you will be able to solve these questions with ease. Okay, so that's about it for this video and the entire fractions module. We will come back and touch on the topics, because see, the thing is, I cannot talk about fractions entirely if I've not covered factorization and I've not covered exponents and algebraic expressions. So that's what I'm saying. We have to look at this more as a terms basis. After, like in every term, after we've completed everything, we will come back and make reference to these videos and back to make reference to all of this notes so that we can tie everything up. Right, so you can leave a few pages for fractions, for this fractions part, because it's going to actually lead to the topic of rational expressions. Okay, so that's about it for this video. Okay, it's also very important to note that although we use the LCM approach here, we could have used the property to solve this question. And that's the reason why I had to discuss the properties first, so that I can show you that these ideas still link and they still work for anything. So what is the property where we can add fractions? Is we multiply the denominators together. So 4 times 2 is 8. X squared times y is x squared y. 1 times 4y is 4y. And 2x squared plus 2x squared times 1 is plus 2 squared, right? But I obviously cannot go in depth with this approach. All I have to say is that both these answers are the same, right? But if I have to simplify it here for you, just because you haven't done factorization yet, you will get to the same answer. So what I can do is I can put out 2 here, and I can say 2y plus x squared over, and 8x squared will just be 8x squared y. Right? Can you see the 2y and this? Can you see they are the same? The numerator and the numerator are the same. So therefore, I'll have 2y plus x squared over, and it'll be 2 divided by, or I can cancel a factor of 2 here. That will leave me with 4x squared y. And that's how we can get both the same answer. Right? Again, like I said, maybe this part here would have confused you a bit, but we are getting to that section. This is the reason why I am going to, like I said, we have to get to the point where we have to get to the part where we have to think about these topics on a terms basis. So at the end of term 1, you'll be able to do all of this. And I cannot teach you everything in one video because everything links. It's like you're missing a chapter now in order for you to understand the story fully. Right? So think of this from the perspective of terms. So at the end of term 1, you'll be able to do all of this quickly and easily.